Hello friends, let's see another question from electric circuits and network. Here in this question, an AC source of voltage ES and an internal impedance of ZS is connected to a load impedance of ZL. Consider the following conditions in this regard. Okay, four conditions are given. XL equal to XS if only XL is varied. XL is equal to minus XS if only XL is varied. R equal to root of R square plus XXS plus XL whole square if only R is varied. ZL, mod ZL is equal to mod ZS if the magnitude alone of ZL is varied, keeping the phase angle fixed. The valid conditions for maximum power transfer from the source to the load are. So, maximum power transfer theorem. This question is based on maximum power transfer theorem, and we have to find which of the following statements are valid conditions. So, four options are given. From that, we have to find which of the statements are correct about maximum power transfer theorem. So, before answering this question, we will see four cases for this maximum power transfer theorem when we see in case of AC circuit. In DC circuit, we know RL is equal to Thevenin's resistance or internal resistance RS. Here they have given RS or ZS as the internal impedance or Thevenin's impedance. Since it is AC source, if it is a DC source, we know RL is equal to RS or RTH, Thevenin's resistance. But when it comes to AC source, we have to divide the circuit in four cases. Okay, first case, since there are XL components are present in AC circuit, we have to consider these four cases. First case means both the load resistance as well as load reactance are variable. Okay. When RL and XL are variable, the load resistance RL can be found by the formula root of RS square plus XL plus XS the whole square. We know in such conditions XL is equal to minus XS. By substituting this minus XS in the first equation, we can say that RL is equal to RS. Okay, that means the two conditions we have to understand while varying RL and XL are present in a circuit. Variable RL and XL are present in a circuit. We have to think that XL equal to minus XS and RL equal to RS. That means ZL is equal to ZS conjugate. If ZS is RS plus JXS, then ZL will be RS minus JXS. Okay. Only in case 1, we can use the maximum power as, the formula for maximum power as VTH square by 4RL. In the coming other three cases, we cannot use this formula for finding the maximum power. And since this ZL is equal to ZS conjugate, efficiency is 50%. Now let's see case 2, where RL is variable and XL is constant. Okay, XL is a constant value and RL is variable. In this case, RL is equal to root of RS square plus XL plus XS the whole square. That means the RL value will be greater than the RS value. Okay. And also RL can be written as modulus value of ZS plus JXL. Since RL is greater than RS, the efficiency will be greater than 50%. Now let's see case 3, where ZL is equal to RL and load reactance is 0. When the load reactance value is not there, then ZL will be equal to RL. In such a case, the load resistor RL is equal to root of RS square plus XS square, which can be written as, that means load resistor RL will be mod value of ZS. Okay, here also the RL value is greater than RS, Therefore, efficiency is also greater than 50%. To find load power, VTS square into RL divided by RL plus RS the whole square plus XS square. Okay, why I am telling all these cases? Because after understanding these cases, when we move on to the options given, we can clearly understand what the statements are said exactly. Now let's see case 4. RL and XL are varied by equal percentage. Okay, that means we know the load impedance angle tan theta L is equal to XL by RL. That means load impedance angle theta L is equal to tan inverse of XL by RL is a constant. This is a case where both RL and XL are varied, but they are varied in equal percentage. Therefore, this load impedance angle becomes a constant value. In such cases, the load impedance is equal to the modulus value of load impedance is equal to the internal impedance or Thevenin's impedance. Here also the power value we have to calculate with this formula VTS square into RL by RL plus RS the whole square plus XL plus XS the whole square. Here theta L is a constant, we already told. That means RL can be founded by Zl cos theta L and XL can be founded by Zl sin theta L. Understood? Okay. Now let's see the statements. Okay. First statement is XL equal to XS if only XL is varied. We saw in first case itself, it is, even though it is written as both RL and XL are variable, here we can also see the option with when XL is varied. This option can also be related in case 1 also. When here XL is also variable, right? So when XL is variable, we know XL should be equal to minus XX. It cannot be equal to XS, it should be equal to minus XS. Okay. So option 1 is wrong and option 2 is right. Okay. Now, if only RL is varied, okay, let's see here also RL is varied, but here RL and XL are varied. In second case, we know RL is variable and XL is constant. Here, RL is equal to root of RS square plus XL plus XX the whole square. Okay, let's see the option 3, RL equal to root of RS square plus XS plus XL the whole square if only RL is varied. Now I hope you understood this option also, how we got this option also correct. That means 1 is wrong, 2 is right and 3 is also right. Now let's see, is mod Zl equal to mod Zs. If magnitude alone of Zl is varied, keeping the phase angle fixed. This is the case 4. In case 4, we learned that phase angle or load impedance angle is constant, fixed, and XL and RL are varied in equal percentage. Here what we learned, mod Zl equal to mod Zs. Now let's see the option. The Zn 4 itself says the same case 4. That means mod Zl equal to mod Zs and keeping the phase angle fixed. Okay, so the valid statements are 2, 3 and 4. Let's see the option. Option D is the right answer. 2, 3 and 4 only. Okay, hope you understood this question. If you have any doubt, please ask in the comment section. We will meet with another question in another video. Till then, bye bye.